Let's look at some examples for Kepler's third law. First, let's calculate Jupiter's orbital period given that its semi-major axis A is about 5 astronomical units. This means that Jupiter orbits the Sun at a distance that is approximately 5 times larger than Earth's own orbit. So we start with Kepler's third law itself, p squared equals a cubed. Now we have to plug in the values that were given to us in the original problem. Here we were told that the semi-major axis A was about 5 astronomical units, so we replaced the A in the equation below with 5. 5 cubed is 125. So to solve for p, we have to take the square root of both sides of the equation. The square root of 125 is about 11.18. So we have our orbital period, p, equals 11.18 years. But we have to give our answer with the same amount of significant figures that were given to us in the original problem. In this case, just one, since there's only one significant figure in the problem itself. To determine where and how to round our answer, start counting the significant digits in the original answer from the left to the right. The first digit itself is already significant, so we have to cut the number there. Looking at the digit next to the first one, we determine that we must round down, not up, since the digit that was pointed out just now is less than 5. So we round our answer down to 10. This means that it takes Jupiter approximately 10 years to orbit the Sun just once. In our next example, we'll calculate Pluto's semi-major axis, given that its orbital period is about 245 years. This means that Pluto takes 245 years to complete one full orbit, just one. It takes more time for Pluto to do this than we've even known about the planet since its discovery in 1930. So, just like last time, we start with Kepler's third law, p squared equals a cubed. We know the value of p, so we plug that in and we get 245 squared equals a cubed. Now, 245 squared is 60,025, so 60,025 equals a cubed. Now, to solve for a, we have to isolate it, so we take the cubed root of both sides of the equation, and a ends up being equal to 39.154 astronomical units. But we're not done yet, since we still need to determine how many significant figures our answer should actually have. So we look at the original problem. 245 has 3 significant figures, so our answer also has to have 3 significant figures. So we start counting. The first 3 digits in our answer are all non-zero, so they are each significant, meaning that we cut off our answer after that third digit. The next number over is a 5, which means we have to round up to get our final answer. Our final answer will be 39.2 astronomical units, which has the desired amount of significant figures. This means that Pluto's orbit is almost 40 times bigger than the Earth's. In our last example, exoplanet Kepler 37b, a moon-sized planet orbiting the star Kepler 37, has an orbital period of 13.37 days. So how far from its parent star is this exoplanet? To solve this, we'll use Kepler's third law again, but we have to remember that this law requires the orbital period be given in years and the distance in AU. In our question, we have 13.37 days. We need to change that number to represent the same amount of time in years. So after dividing by 365.25, since there are 365.25 days in each calendar year, we get 0.0366 years, and this is the number we'll use for p, in p squared equals a cubed. Plugging that in, we get 0.0366 squared equals a cubed, and 0.0366 squared is 0.001333956, so that's equal to a cubed. Again, to isolate a, we have to take the cubed root of both sides, and we find that a is equal to 0.11024. Here we have to round to 4 significant figures, since that's how many significant figures we had in the original problem. So again, we start counting our significant figures in our answer. The first 0 is not significant, so we don't include it. Then we count and find that here is where we're cutting our answer. Looking at the 4 just beyond the cutoff, we determine that we don't need to round up. We'll keep the number as it is, so our final answer is 0.1102 AU, which is approximately 16 million kilometers, or just shy of 10 million miles. So that's the size of the orbit of Kepler 37b as it orbits Kepler 37, its parent star.